The Sustainability Research Network, or SRN, is an initiative funded by the US National Science Foundation to bring together some of the very best minds from research universities, from industries, from cities, and from policy organizations to come together and work on this challenge of urban sustainability. And the urban sustainability challenge is that we know that by the year 2050, we're expecting 3 billion more people to be living in cities. And we have no idea how to build infrastructure to accommodate that future growth. And so the research focus of our SRN is on infrastructure as a way of building better cities of the future. And what we're doing in this SRN is saying, can we really rethink or reimagine our power grid, our energy supply systems, our water supply, our wastewater systems, our food supply and distribution systems in ways that can improve the health of people living in cities, in ways that are more protective of the environment, but also ways that create this intangible thing we call livability. It really attracts people to come and live and work in cities. And that is the focus of our SRN. One of the first tasks in our research network is to develop the science and the analytic tools to measure how these things that we care about, environmental sustainability, health, and livability, are shaped by these different infrastructure systems.
Our team will be measuring, for example, air pollution within the cities caused by activities within the city boundaries, like from traffic. We'll also be tracking the impact cities have on the environment outside of their boundaries by tracking, for example, how conventional energy supply to a city from a large power grid can impact air, water, and land many miles outside the city.
We will also be measuring how people feel emotionally when they experience the physical infrastructure in our cities, our buildings, roads and transit-ways, green spaces, urban farms, waterways, and energy supply systems, particularly when cities are stressed by extreme events like heat or flooding.
We will be exploring these methods in diverse cities like Minneapolis, Atlanta, New York City, as well as cities in India.
Another key question we are asking is, can we reimagine and redesign our urban infrastructure systems to become more distributed? In other words, to have more local elements. Will more locally produced food and locally produced electricity help benefit the environment, public health, livelihoods, and livability? Or will there be trade-offs? How do people, both individual and policymakers, make decisions among these trade-offs? These are complex issues, and the exciting part of our SRN is that we are partnered with several cities and universities who are engaged in real-world experiments in distributed infrastructures, which we call our testbeds.
Our testbeds span different scales: home, community, the city regional scale, and beyond. And for each testbed, we explore not only the physical linkages of infrastructure across scale with the larger natural systems, we're also exploring how people at these different scales respond to new innovations.
The City of Tallahassee owns and operates its own municipal electric utility, and we offer a number of programs that are intended to engage citizens in energy conservation. We have worked with Florida State University to analyze household-level demand-side management participation and household energy consumption data.
At the scale of the individual user, combining utility data analytics with careful survey research can help us understand what motivates households and businesses as individual units to adopt conservation and efficiency measures.
Like Tallahassee, the City of Fort Collins also operates its own water and electric utilities. In addition to household programs, the city has initiated innovative community-scale solar garden programs. Colorado State University, located in Fort Collins, houses a state-of-the-art Intergrid laboratory for simulating the integration of such distributed renewable energy into a microgrid. This lab can simulate microgrids in lower density cities like Fort Collins or in dense high-rise areas of New York City, such as those being studied at Columbia University.
Connecting distributed generation to the larger electric system and addressing regional transmission challenges and environmental issues are all critical to create a more sustainable energy system.
At the household scale, people make decisions about their mode of transportation every day. Minneapolis was among the first to initiate a bike share program called Nice Ride. Our faculty has access to survey subscribers of the Nice Ride program. These surveys are very useful in understanding both the barriers and motivating factors for riding the bikes, and also in tracking other study parameters relating to health and well-being. Surveying car share users in Minneapolis and Austin will help us understand another aspect of transportation choices with a larger travel range. When thinking about larger range travel, Minneapolis also has two major light rail lines, one of which started service in 2014 and runs through the center of the university. We will be tracking riders on this new line to better understand public transit use and planning within the city and greater region.
The water wastewater testbed begins with understanding behavioral change at home, not only to conserve water, but to reduce the use of pharmaceuticals and personal care products like triclosan.
A key question to ask is whether community behavior change campaigns can reduce the amount of these pollutants being released into sewers. Minnesota researchers will be partnering with the Metropolitan Council to run these neighborhood campaigns where they will monitor the sewers for personal care pollutants to see if behavior actually changed.
University of Minnesota researchers are also developing customized microbial treatment systems that can be used in modular form to treat a variety of pollutants in industrial and municipal wastewater. This can have a lot of applications in distributed community-scale water and wastewater treatment. For example, one application that we're really excited about would be the community-scale aqua farming that they're currently pursuing in Detroit.
If all cities in a region adopted distributed water and wastewater infrastructure, what would it mean for the utilities and the watershed? Will it help cities better cope with climate change?
Researchers at Columbia University have been working on the technical challenges to implementing green roofs in New York City's buildings.
Using low-cost soil moisture probes, along with local precipitation data, we can capture daily changes in soil water storage.
At the community scale, the Columbia University team is collaborating with the University of Michigan to compare and contrast urban farming in New York City and Detroit. Detroit Future City is an organization tasked with revitalizing the community.
Transforming vacant land is a key underpinning of what we do here at Detroit Future City, and we believe that green infrastructure and urban farming and community gardens are two of the primary mechanisms that we have of creating a healthier city, a city that people want to live in, and attracts new people, that people want to stay here in Detroit and come to our great city.
So one of the things we're doing at the University of Michigan is using a geographic information system to study and identify what we call transformer parcels. And these are parcels located in neighborhoods and at the city scale that have the optimal benefit for transforming certain neighborhoods.
Connecting social and demographic features at the city scale with regional climate models can help identify those transformable parcels as a pathway to urban sustainability.
Insights from all the test beds together will be used to model future cities, to explore how infrastructure and policy decisions made today can shape sustainability, health, and livability outcomes in our cities of tomorrow.
Our test beds and development scenarios will include new and disruptive technologies. For example, driverless vehicles, electric vehicles, customizable wastewater systems, and different technologies that could have a big impact on the environment of cities.
These test beds are also fantastic resources to create new education models for students in our SRN.
We also greatly value outreach to K-12 education and the opportunities this SRN offers to strengthen learning at that level.
With policy partners such as ICLEI USA, National League of Cities, International City Management Association, and Partnership for Public Spaces, this network has the capacity to translate science into policy in a network of 30,000 cities in the USA and worldwide.
Cities are interested in new technologies, innovative policies, new ways of financing infrastructure, and of course, engaging the public in sustainable behaviors.
The engagement of cities, industries, and policy partners is a real strength, so that the research questions are being posed right from the start, with practical and real-world impacts in mind.
And what's really exciting about our SRN is that we have a structured way to come together in research, in education, in policy, and in community action to build phenomenal cities of the future.